Welcome, everyone. This is our panel discussion on making data actionable. Thank you for taking your time to attend this. This is panel discussion. We're going to do some brief presentations from our panelists today. Then we will go into questions and answers, any questions that you have. We have some pre-canned questions to get the ball rolling if need be as well. So. But thank you again for your attendance, and I'm going to pass it over to Paul Ehrlich.
Thank you, Robert. As Robert said, my name is Paul Ehrlich. I'm the founder and president of a company called Building Intelligence Group. I've been in the building systems industry for the last 30 years. A lot of my work has involved the development of control systems, and for the last almost 20 years working with owners on implementing system integration and planning and solutions around efficiency and optimization. Most of my work these days is focused on research-focused efforts. I work very closely with the national labs, as I do with the BEST Center. And I understand that in your last session, there was discussion about some of the work being done in the controls description language, which is something I'm very involved with. I wanted to talk for a few minutes about the importance of building data and where building data comes from and why we're some of the challenges we have with it and some of the opportunities that we have with it. You know, when we think about building data, it starts with building controls. So when we have a building control system, we have a series of sensors and actuators, inputs and outputs that form control loops, and they fit into our control logic. And we install all of these pieces and parts into that building in order to do control. So it's in order to keep the building comfortable and efficient and healthy and safe. And that's why we put them in. But because all the control systems we do today, for the most part, are networked, we can now see that data. So that data can become available for other uses. And if we think about it, there's all kinds of things we'd like to be using that data for. We'd like to use it to make operational decisions. So we want to know if a value or a point is in range or out of range, if it indicates a space is too hot or too cold, or if a piece of equipment has failed. We want to use it for analytics. Are we running more efficiently or less efficiently than we were last year? Is something broken? Does something need to be, could something be operating better than it is today? We want to be using that data for maintenance. We want to be doing things like at a very simplistic level, like tracking the number of hours that something has run or the number of starts a piece of equipment has had and scheduling maintenance. But at the other end of the maintenance world, we want to start moving towards predictive maintenance, looking at data and the characteristics and the operational characteristics for when we might need to tear something down or replace it or schedule its maintenance. We can use data for optimization. And at the far end of the world, we can use this data to form what we call digital twins. And digital twins are actually buildings that run in a model, in a simulation world, and they use and look at that real world data from the building to make what if decisions. So for example, I know there's been a lot of sessions about grid optimization and energy efficient buildings. If I want to know what would happen to my building if I increased a set point now, what would the reaction be in 3 hours? That digital twin is the kind of tool that will allow us to do it. So there's a lot of value in having the data and analyzing the data and using the data, but there's also a lot of challenges as well. So that building control data can also be brought in and combined with other data. So if I take the data about temperatures and pressures and run times and all kinds of characteristics of my HVAC system, and I bring that in with my metering data, my utility meters for energy or for electricity and gas at the building level, my sub-meters spread out throughout the building. And then I start bringing other data together with it. Security data, when is the building occupied? When's it unoccupied? With the weather data, what's the current weather and the highs and the lows and the anticipated weather for the next day? We can bring it in with business data. Wouldn't it be valuable to know what the reactions was and what was going on in that classroom, and also have the class schedule as a piece of business data and look at that in parallel. And we also would like to bring it in with other pieces of related data like design information. I worked with an owner years ago, and they said, we just built this facility. This is actually in India, and we believe it's the most energy efficient building we have in the world. Is that true? I said, I have no idea. Do you know? They said, well, we don't know. I said, well, how do you don't know if it's efficient? Well, the first thing you have to do is you have to normalize the data and baseline and benchmark and compare it. So that's an example of combining data to make sense out of it. But there's some real challenges to doing this. And as an industry, we've been struggling with these challenges. The first challenge is just simply being able to extract and get use and access of the data. That's been a real challenge. It's been simplified as control systems become network enabled. It's been simplified as we've moved to open interoperable standards like BACnet. So now I can actually connect to a control system and pull back all the data. But what do I have now? I've got stuff. I've got bits and bytes, and I've got something that says zones sensor 106, or maybe it says zone 1-232. What does that mean? Is that sensor, is that piece of data a temperature? Is it a set point? Is it a room number? What is it? So one of the big challenges we have is that we need to attach references, relevance to that data, and that technically that's what we call semantics. So the semantics and the language that we use, what we call the ontology, becomes really critical. And there's two major ad hoc efforts that have taken place in industry. There's an organization called Project Haystack, and there's another organization called BRIC that have done a great job starting to create semantic data standards. And now ASHRAE is working on a project called ASHRAE Standard 223 or 223P proposed that is trying to create an entire semantic model of the building and the building systems. So there's a lot of work going on to create and define those semantics. That's a big hole. The other big challenge we have is integration. Boy, we design and build buildings in a non-integrated fashion. So the HVAC system designer may be doing the control system, and somebody else over there is doing the gas distribution system, and those are two different systems, and they don't easily integrate. And I'd like to know what's going on with the UPSs in my data rooms, but that's over in the IT system. So bringing that data together, that integration is a challenge. And then we have a couple of other major challenges. One of the problems with data is it's just data, it's bits and bytes, and we've got to make sense of it. So one of the challenges is to move data from being raw information to being knowledge to being action. And to do that, there's been a lot of tools created, different ways to present that information, to analyze that information, to help make some decisions, to do what we call fault detection and diagnostics. And there's a lot of commercial tools that are readily available today to do that. And then the final thing we need, and this ties us full circle and gets us ready for our presenters, is training. So how do we teach people, how do we teach building operators and technicians about the importance of data, how to analyze data, and how to use data? So on our panel today, we have three speakers. Our first speaker is Paul Reale, who is with the Building Performance Lab at the City University of New York. And Paul is working on a project that I'm nominally involved with on the edges as an advisor called Building Coach, which is using building data for training. And then we're going to have John Elliott and Raphael Vitti, who are the chief sustainability officer and data analysts with Lawrence Berkeley National Lab, and how they're using data from an operational perspective and some of the commercial tools that are available today. So with that, Paul, I'm going to ask you to go first, if you'd like, and talk about what you're doing with Building Coach.
Wonderful. Thank you, Paul. I appreciate the introduction and your opening remarks. Those are really helpful for setting the stage. So good morning and good afternoon, depending on where you are. I'm Paul Reale with CUNY's Building Performance Lab. And I just want to jump right in and tell you about the problem, which, and I know this seems like kind of a mundane problem. It's something that Paul mentioned, which is that operators need training. But more specifically and more pointedly, it's for buildings to run efficiently. I would say that operators need to be trained. And I know that a lot of you are thinking, well, we're migrating to these more advanced and energy efficient sequences of operations. And that's very much true, but keeping the operator involved, making sure that the operator understands how these things work is absolutely critical, because their most common paradigm is to do whatever it takes to make sure that the occupants of the building are happy. And that often means overrides, right? And what I have found in my experience of working with building operators over the years, is that the less the operator knows about their systems and the controls associated with them, the more likely they are to override those systems. So that's really kind of where we're coming from. And one of the very useful approaches to running buildings more efficiently is, sorry about the construction. One of the key solutions is the Pacific Northwest National Lab has developed building retuning, which I'm sure many of you have heard of. They did that more than a decade ago. It's an extremely useful method. I'm sorry, I hope that's not too noisy in the background. A very useful method for optimization that operators can understand if it's posed and delivered in the right way. So, a very simple example would just be fan status in an air handler, on and off, and just looking at it over time. These are all time series trend charts, and that a fan status, if you compare the status of the fan relative to the scheduling for the building, the operator can easily interpret that. The solution then is to take that basic idea from PNNL's building retuning. And we at CUNY's Building Performance Lab, we did that. We took that basic idea, we streamlined, standardized, and added scores of trend charts to look at central plant, air systems, distribution systems, perimeter systems. And we have been coaching operators and energy managers. Now, this is, in fact, January, this is our 5-year anniversary of doing this, of having done this. Mostly in New York City, but also in other places in New York, down in Washington, D.C. We've been moving out there, and we're now obviously going beyond that. And the idea is to help them understand how to set up these trend charts, get the data from their buildings, from their building automation systems, and analyze them to see where their systems are operating optimally. And that analysis part might be where you cringe, right? How am I going to get a building operator to conduct an analysis? Well, it's really, if you lay it out and you train them on, here's what you're looking for, ask the specific questions that can be answered with a simple trend chart, they can do that. They know how to do that. So we get together with them in these coaching sessions. We look at the trend data from the participants' building systems. We look for those opportunities for no cost, low cost changes in operations, right? This is really making the best with what you've got. And you've all heard the numbers before, 14, 15% opportunity here on average for running a building more efficiently. And that's a big bite. It really is a big bite. And so that's what we're really after here. So our challenge, though, one of our biggest challenges is in coming up with the trending data, with coming up with good trend charts, because it's not well standardized in the industry, as many of you know, with the building automation systems, or there may not be good graphics associated with it. It doesn't show it clearly. The ability to actually set up the trend chart is not easy. But we've come up with a solution working with our partner, Intellimation out of Philadelphia. We're using something that we call the box. And the box, it's BOCS, the Building Operator Coaching Solution. And this is a combination of hanging essentially a Voltron solution with some other protocol stacks tied into the BACnet network, pulling the data off of the network, and sending that to the cloud, where we leverage the scores of trend charts that we've created at CUNY's Building Performance Lab. And we make these charts available for all systems at all times. So they don't have to go through the pain of setting up the trend charts. So rather than doing the kind of automated fault detection and diagnostics and the analytics in the cloud, we're making the information available to them. And we're very convinced that the operators understanding that data helps them rely more and more on the automation as it slowly creeps its way, more of it creeps its way into their systems. So that's been very helpful. And so we are now leading an effort with the Department of Energy, with their support, developing a platform and a curriculum for remote coaching. We call it Building Coach. And we're running a pilot of this program starting soon. We're going to be starting this year with 100 operators from 40 different buildings. So that's the idea. And the net result, of course, is essentially what can I do to fix things? And in a lot of cases, it's just changing a set point. It might be doing some troubleshooting, finding out that maybe some control leads are swapped. Maybe there's a bad sensor, needs to be calibrated or replaced. Actuators out of whack, things like that. So the troubleshooting piece, but then also, is the scheduling right? Are the set points optimized, and the like? And going across the board for your chiller plant, your condenser loops, condenser water loops, and hot water distribution, you name it, air handlers and so forth. So the coaching program that we've developed, in fact, why don't I just go ahead and share very quickly the website so you can see this. Share a screen. There you are. So this is building-coach.org, and this will give you an idea of what's going on. We're launching this year, the pilot program, and that's all fully funded by the Department of Energy. So this is all really getting into the nitty-gritty and trying this out for the first time. So we're looking forward to launching our pilot. That's coming up soon. So that's the solution. We feel that it's a no-brainer when it comes to a cost-benefit analysis. Obviously, when the operators know what's going on and they're doing the work themselves in terms of optimization, it's obviously of great benefit. And the program itself includes self-paced modules, online training, so synchronous training. There's 2 training sessions, as well as 5 coaching sessions where we get together and we actually look at their specific systems and see what's been going on for the last couple of weeks. How are these air handlers running? How's your chiller plant running, and so forth. And then after that, we envision an ongoing, very inexpensive subscription service that provides ongoing access to the trend charts so they can continue to use them. A repository of their building documentation, which will be secure so that they have it all kind of organized for them rather than, in a disheveled pile, which is often the case for a lot of buildings. And then we can also offer a regular coaching session, maybe once every 6 weeks, to see how's it going on trying to get these things, up and running, maybe a new sequence, new set points and things like that, and checking for new opportunities as well. So that really wraps it up. I just wanted to kind of give you a feel for what it is we're after, what we're doing, and we really do believe that it's going to make a difference for the people that participate. So thank you.
Thanks, Paul. And I think we're going to go through all of our presenters today, then we're going to open up the floor for questions. So John, would you and Raphael like to go next?
Sure, that sounds great. And that's very exciting work, Paul. Raph and I are going to start off with a rapid fire visual overview showing some ways in which we're using data analytics in our buildings at Berkeley Lab. And just for context, we focus on about 20 of our most energy intensive campus buildings. We're integrated to a wide range of meter data and sensor and actuator data from our various building automation systems. And roughly there's about 20,000 active data streams that we're currently maintaining. So if we go to the first slide, here's just some different examples. So this first one is a relatively simple example. It's just analyzing monthly utility bill data, and it's doing it with simple systems. We have the data in Google spreadsheets, and this is using Tableau, a third-party reporting tool that many use. But you can get quite a bit of insight. This is a chart for each building. 3 of them are shown here, and you can get a breakdown by energy source. This is showing electricity and natural gas consumption in orange. You get a sense of that consumption profile over the months and seasons. And then we have one metric in the line, which is a rolling 12-month energy use intensity. So you can answer a very simple question, is efficiency in this building getting better or is it getting worse?
This next example, and I skipped, sorry about that. This next example is also quite simple, but it's very powerful. What we are doing is we are showing trending data in context. And so here, this specific example is for zone level data. And along with that data, we're displaying relevant trends from the air handling unit that is serving the space, as well as work ticket information at the top and the results of automated fault detection algorithms. And so that really helps put the data we're looking at into context and helping the operator make sense of it.
Great. In this case, we're processing data, IP address data flowing through all the internet routers across our entire site. And from that, we get counts of internet connected devices. And from that, we can infer an occupancy schedule. And then we can compare that inferred occupancy schedule to the actual schedules that are applied to all of our air handlers. So here's a view in which we're looking for opportunities. We have on the x-axis a week, and then on the y-axis, we have a whole bunch of air handlers. And we're looking for opportunities. Those are marked in orange here. So that's when we think that there's no one in the space, but yet the air handler is scheduled on. So that allows us to focus our efforts to trim those schedules.
Now, the next one is a calculation and a visualization that we created based on a specific request from our technicians on the ongoing commissioning team. And we're using here temperature data and reheat valve commands to calculate a metric that essentially shows whether we are getting the heating that we're expecting in our terminal units. And so a zone where the reheat coil is clogged or the reheat valve actuator is broken and the valve is in the closed position will show here in blue and be easily identified even when you're looking at 30 or 40 zones like we're doing here.
And this is one of the views that we use to help manage our big cooling plant at our large high performance computing facility. We often use this scatter plot view. It has weather along the x-axis, relative humidity, and then on the y-axis, often we're looking at energy consumption. In this case, we have a ratio of energy consumptions, and we're looking at a high-level efficiency metric for the data center called PUE. But this gives us a time differentiated view, so we can establish a baseline period and then compare it to a performance period, which is shown here in red. And in this way, we can identify if there's been some excursion from that baseline or that desired performance level. And you can see with those red scattered dots, something was happening during that period, and we'll go ahead and investigate that and figure out whether we need to make a change to get ourselves back in line and retain the efficiency that we had achieved at the baseline.
And in this final example, we go a little beyond fault detection, and we actually are sending feedback to the control system to better inform, in this case, a supplier temperature reset at our air handling units. So what we're doing is we use fault detection to identify zones with specific problems. For example, one of the main one would be a leaky reheat valve. And for a zone with one of those problems, such as leaky reheat, we're telling the control system, well, don't let that zone ask for colder air, because otherwise it might drive the temperatures of the entire system down and give more work to the rest of the terminal units.
Great. So slideshow is over. And we'll now provide just a few takeaways that are based on our data analytics work in the field over the last several years. So I'll start and say first that I'd like to validate one of the messages that I've heard throughout this year's BEST Institute meeting and confirm that it's very much true at our site, that energy efficiency, which for us really means ongoing commissioning in buildings driven by analytics, is the foundation for our overall decarbonization strategy. So we're achieving reductions in EUI and in overall consumption in the range of 20 to 30% across our building stock. And this really makes those next steps of decarbonization, adding renewables and electrification much, much easier. Second, we're talking about making data actionable. And in this discussion, I often find that people like to focus on selection of tools and algorithms and maybe visualizations. And that's all very well and good. But often the discussion skips over the question of how you will actually take action. So do you really have an ability to act on the data? You know, are you really set up to fix the complicated problems that we find in our buildings in a timely manner? When we started out, what I found at our lab is we had the capability to fix buildings. We had people with the skills, but they were really not organized in a way to be successful at all, really. So we put a lot of effort into building an ongoing commissioning team with skilled controls engineers and HVAC technicians, and developing their capabilities, allowing them to focus and not get pulled all over the place with work tickets flying everywhere, and really focusing on establishing a rigorous process for directing their efforts. We just call this our ongoing commissioning approach. And we have a nice about 10-page write-up. So it goes in quite a bit of detail describing it at a website. It's ocx.lbl.gov.
And great, now I have a couple of takeaways as well, coming from the side of the technical side of setting up data analytics at our site. The first one is that one thing that's easy to ignore when you're looking at examples of data analytics from somebody else, just like we did, is data quality. And in practice, data quality is a huge issue, and cleaning up data is a lot of work that can't be ignored. For a start, you have to make sure that you are using the right data streams when you're setting your system up, which actually takes quite a bit of work and may actually require an understanding of your controls logic. And then for important data, such as metering data, you need to review it on a regular basis to make sure that it is valid on an ongoing basis. So all of that is a lot of work. And a second takeaway is that you actually can do a lot with simple analytics. And several of the examples that we started with use actually no mathematics at all. They're just visualizations of data, or use very simple math. And so I think that's important to keep in mind, and not get discouraged by some more complex algorithms that you might have in mind.
So that's it for us. We're ready to go on to questions.
Great, thank you so much for everybody. Raph, your point about metering and accuracy is one that it just made me recall something. I worked with a large office building tower owner at one point, and they had submeters set up, and they were submetering data center floors for a bank that had several floors of their building. And we started looking at that data as part of our analysis of the building, and to recommission and redo the controls, and realized that they were 1 digit right of decimal off. They were off by a factor of 10, and they've been charging the bank wrong for many years. Right. It's so easy to have the data be wrong, and for nobody to ever notice it. And it wasn't until we said that we had this into a sophisticated energy model, we couldn't make any sense out of it. And we said, well, gee, if we just move that by 1 decimal point, it makes sense. But it's easy to get it wrong. So
yeah, maybe 40 to 50% of the time when you first encounter the data, it's wrong in some way.
Yeah, exactly.
So.
Exactly. So Robert, are you going to ask us questions? How are we going to do this?
Yeah, if I may, I think that
would be great.
Given I was planning on addressing Bob Clark's question here first, but your statements right here really lead into a great question. When we're setting up and working with systems like data analytics, fault detection, all of those types of systems, how do we get to the point where we can trust the data the system is giving us?
I can get started with an answer on that one, and I'll say it's an iterative process, and unfortunately there's no simple answer. What we were referring to earlier with the metering data is a good example where it's important to keep an eye on it. It's also important to have people in the field who can do testing. I think that can't be bypassed. In many cases, with work we've done at the lab, we've actually had to set up almost as many visualizations that are meant for us to review the data quality compared to the number of visualizations that are meant to take action. So you need both, and it's an ongoing process.
I'd like to add to that and just say that, yes, I resonate very much with what you said, Raphael, about it being an iterative process. If you look at the data, if you look at the trend data, however you're going to look at it, our way of looking at it is typically time series. If you keep looking at that data from different perspectives and ask different questions about those data, that's when you can reveal that, hey, there's something wrong with this information that's emerging from these data. The mixed air temperature isn't between the return and the outside. That's a problem. You know something is wrong, as a simple example. So yes, constantly asking more questions about the data, I think, helps to build trust in the data.
But it is a significant challenge. So for example, if we look at a data point of a temperature in an air handler before a heating coil and after a heating coil, and the one after the heating coil is hotter and the valve is closed, we want to come to the conclusion that the valve is leaking, but we can't because it may be that the sensor is wrong. Yeah. But one of the things that points out is the issue of data and data quality, and particularly of sensor quality, is not just a data analytics issue. This is a major and significant controls issue. We see sensors and actuators and devices that are wrong all the time. I did a retrofit on a project once, and when we went through to commission it, the contractor had put all the hot deck valves on the cold deck and all the cold deck valves on the hot deck, and everything was running backwards. And it's really easy to make mistakes, and it's a challenge to find them and to fix them and to keep them from occurring again.
Right, and to add to that, Paul, I would say it's even a challenge on the hardware side. Actually, our ongoing commissioning team put quite a bit of work into training themselves and getting skilled up when it comes to installing sensors and using averaging sensors in particular. And these are skills that take time to develop.
It's also a challenge for us as design engineers to be thinking about, as you said, Raph, not just what sensors to specify, because we often specify the cheapest one, or the contractor puts in the cheapest one, but also in many cases there may be additional sensors. We only put in the sensors generally in a design that are needed for control, but there may be a very good business case to be made to add some additional sensors that are going to be used for analysis and operations. For example, a pressure drop sensor across a filter isn't needed to control the air handler, but it is an invaluable piece of data to help make a decision about the filter status. So there should be some iteration between what's going on with particularly for a sophisticated owner on the design, on the operation side, and the design side, feeding back what's needed.
Fantastic. I think we'll bring up Bob Clark's question here, which is almost, I think, rhetorical, but it really gets to the heart of what we're looking at with this particular panel, how to make data actionable. Bob asks, do we have any idea how much resources we have wasted capturing data that we never use? I think Paul and Paul would be a good ones to start out with on this one.
I'd almost like to hear Bob ask that question live. I can just imagine him saying it. I've worked on a lot of projects where owners will say, we want to collect all the information on all the data all the times, and we don't know what we're going to use it for, but let's just collect it because, it's just storage, and storage is free. So there is some wasted effort that goes on there, but I'm not sure it's a significant wasted effort. I mean, if you have data and you don't use it, it is just storage, and storage is cheap or free. I mean, it's not a big deal. On the other hand, if you don't collect it and you want to know if you want to know how your building's running this year versus last year or 2 years ago, and you don't have that data, you can't make those decisions. And that makes it a difficult thing to do.
Yeah, but I'd like to add also a lesson I learned as a young engineer is if you're not going to do anything with the information, then stop asking for it. If you don't know where you're going with it, right? I mean, then the danger there is that you've got, many more piles of data than you know what to do with, and you can lose the thread of what it is that you're looking for. So it's very important to intentionally gather data with a specific purpose in mind. How is this going to change how I'm going to run my building? And if you don't have an answer to that question, my argument is, well, find an answer or stop collecting it.
Yeah, if we bring that back to the discussion of data quality, you will not be aware of the data quality problems across that whole wide scope, and you won't be able to solve them or stay on top of them. So there is a real value in saying, well, what question am I trying to answer that I can act upon? And that will be a much, much smaller scope of data. And then it'll be manageable, and you'll be able to really figure out, oh, there is some serious weird things going on here, and you'll start cleaning up that data quality, and then you can effectively act on that data. So Bob brings up a great point.
I want to punctuate that just a little more, and just to say, I've heard people say, this building, we have 70,000 points that we're tracking. And I think, and a lot of people might say, oh, that's wonderful. And I think, oh, that's awful. That is way too much data. There's way too many points. You've really got to boil this down to the stuff that you're really the salient information that's going to, make something actionable.
Make sure you can see the trees for the forest.
Mm-hmm. And I'll extend a little bit upon that by saying that beyond collecting the data, also what you might have a situation where you're spending a whole lot of computer time, processor time, running algorithms that are not being used, and that does use real energy. And so, going back to one of the key takeaways that John presented earlier, I think it is important to have those processes in place to make sure that you have the right staffing to act upon whatever algorithms you have running.
Fantastic. Larry asks, this is a question to Paul Reale. Can you share some examples of CUNY's BPLs, infographics, and how they are an improvement over what might typically be provided by an EMS?
Right. So thank you for that question. Actually, I'm going to direct you to the building-coach.org website and to go to the learning portal. And in there, there's a video that shows, in that short video, it shows a couple of examples in there. And that was, and what was the second question, Robert? I'm sorry.
How do they differ from what you see in a BAS? Why is it better than just trying to collect the data in the control system?
Well, I think it actually harks back and resonates with what I was just saying a minute ago, which is that it's relevant and actionable. A lot of the times you see information that the EMS will put out there, and it may not be obvious what you can do with it. Often it is, but sometimes it isn't. And I think the most important thing we can do is to say, not only is this the data, how we can translate it into information, but also specifically, here's what you can do with it. And I think that's critical, just connecting it from end to end.
Fantastic. Thank you, Paul. So next up, this is a question for John. You mentioned the ongoing commissioning team. Is that an extra organizational cost, or have you seen resource cost reductions in other parts of the operations team?
Yeah, thanks for the question, Elliott. We did pursue it in some ways as an extra organizational cost, but in many ways it was just kind of a reallocation of labor that was already there. But I knew that we needed to have a way to really go out and fix things in buildings, or any investment that we made would not produce the long run return over time. One thing we did as we started that is we thought, well, how are we going to present the results of this work? and we set a protocol in place to really carefully calculate any energy savings, both sort of bottom up from each measure and tracking performance at the meter with weather correction, so that we could say, how big our efficiency portfolio was that we were developing. And at this point, we have a portfolio that is saving just over $1 million a year in utility bill savings. We're a pretty big site. And so that then helps legitimate the ongoing effort. And truly, I don't see any other efforts on the site that are effective in solving and resolving these complicated overlaid building problems. We do see, beyond the utility bill savings, we do see that the buildings work much better and that people are much happier. and I think it also reduces things like reactive work orders that were happening before, where a tech might get sent out, but they didn't really have the tools necessary to resolve the problem. So maybe they would just override something, as Paul mentioned. So it does reduce other costs as well, that we haven't really been able to quantify yet, but I'm quite sure is occurring.
It's interesting. I've worked with several large owners, both in doing some research projects and in doing some implementations. And we've gone out and we've surveyed universities, why did you put this tool in? What was your payback? I've talked to people, including Kaiser Permanente and Stanford and others. And almost everybody that uses these tools says, it's part of our business. It's part of our process flow. It's a tool we rely on. We use it for everything. And no, there's not a business case for it. You just have to have it. You have to have a way that you're going to collect and use the data, because if you don't, how do you verify an energy efficiency project? How do you commission a building? How do you, it's just an essential part of operating in a sophisticated commercial space. And owners I've worked with are like, yeah, we get it. We don't need a specific justification for it. You just have to have it. You got to know you need it, and you got to do it. So, but yeah, does it save you? Yeah. Does it save you? Does it cost you $100 and save you $10 a year? It doesn't matter. You have to have it.
Yeah, I'll say honestly, in our environment too, an alternative, which is what people typically think of, is efficiency retrofits. And those projects, led by a project manager and are, have a lot of overhead costs, and it's very hard to get a good return, especially we have very low electricity rates. So we sort of pivoted to focusing on building operations and found that we could really focus on the real savings, and then the payback gets really short and the benefits are really great. So we've kind of gone in that direction for that reason, because the retrofit projects were challenging.
So I think that segues really well into Elliott's second part to his question. Did you need temporary additional cost or support to help manage the transition from reactive to proactive data-driven actions?
I think I may have really answered that. In effect, I did need to get budget to bring the ongoing commissioning team online. And as I said, now I've legitimated that with ongoing savings, and the money continues to flow. So I think I may have covered that.
Additionally, does your institution effectively reinvest the money that you're saving through this process into continuing this process?
We do. We don't have a formal revolving loan fund or something like that, but that is the way we think about it. And so we are looking at that overall portfolio of utility costs and looking at changes in unit prices over time. And in fact, we do a kind of surcharge system through our electricity recharge to help fund these efforts. So we very much look at it. This ongoing commissioning team is one of our key ways to lower utility costs, and we do fund it fundamentally from that savings.
Fantastic. Our next question comes from Elliott. This is for Paul Reale. How would you relate the building coach program to other industry efforts like building operator certifications?
Oh, great question. Thank you. So building operator certification, which by the way, we also provide that training. That's a nationally recognized certification for building operators. And it is an excellent foundation for building operator. If you understand, it gives you an idea of the different systems, how they operate. It has some projects that are building specific, but when we move on to building coach, the idea there is to really spend all of the time focusing on how your systems are running, getting the data for your specific systems and looking for those opportunities in real time for what's happening. And by in real time, I mean in looking at the recent data, the recent historical data and performance, the last week or 2 weeks of data, and getting specific and really coming up with a punch list more than anything else. And the more quickly you can come up with those punch lists, the more quickly you get into those kinds of issues of, do I have the organizational efficacy to actually pick up those items and execute? And I can't tell you how many organizations I've worked with that they're all organized differently, but ultimately someone's in charge of making sure that the sensor is replaced, the actuator is replaced or repaired, and really maybe upgrading the algorithms, the sequence of operations for a given air handler. It may be an older algorithm that is, or an inefficient one. And those things really need to be followed up on. And as those lists grow, you realize, oh, this is opportunity after opportunity after opportunity for energy savings. And you really want to make sure that you're identifying, hey, I've got a problem. My problem is that I don't have the capacity to fix all these things. Well, it's a whole pile of opportunities. So don't you want to? Don't you want to fix that problem? So I find that that's often the case, is that by looking at the right things, you find the obstacles that are in your way, and that you can then say, okay, now I know what the real problem is, and try to knock down that obstacle and then go for the savings.
Fantastic. Our next question comes from Mark Alessandro. Sorry, Mark. And kind of relates back to our, how do you ensure that you have reliable data, that it's real data? But this is specifically related to data transmission. Have you run into any problems with data transmission, particularly in legacy MSTP or LAN type networks?
Let me take an attempt at this. So just so everybody's aware, that this concept of a master slave token passing network, which almost all control systems use some of, is relatively slow and archaic communication. On the other hand, it's typically used for things like VV terminal units, which don't change really rapidly, so we don't really care that much. Generally, most control system architectures have a tiered architecture where some or all of the controllers are on a higher speed network, an IP network, and some of the controllers are on these lower speed networks. When they're tiered like that, generally there's some methodology where the data comes back periodically. So you'll end up with data that isn't completely instantaneous. On the other hand, it really doesn't matter. If a room temperature changed now, or it changes 10 seconds from now or a minute from now, it's not that big of a deal in terms of data collection. So you do need to have some consideration about overloading an MSTP network, but in general, it's not a problem. Most of the control systems can handle it.
Fantastic. Thank you, Paul. Next question comes from Larry. Are data performance and energy dollar savings being corrected to account for higher building vacancy due to COVID?
Well, I will say that we carefully track energy use intensity. We sort of do it every 6 months for the last 12-month period. And so we have a good sense of how energy consumption and EUI has changed in buildings with much lower occupancy. And I think we see, and I've seen this really in every campus environment that's reported similar data, is that we do see a drop in energy consumption, but it's relatively modest compared to the drop in occupancy. So we're talking like 15, 20% drop in energy, even when you're at very low occupancy. It's really pushed us to think a lot more about building flexibility and to figure out ways to improve the turn down of our buildings. But generally, I think buildings are pretty sclerotic. They haven't been designed with a lot of flexibility in mind, certainly large institutional buildings. So it's really highlighted something we all knew, but it was really stark with COVID, where we had almost no occupancy, and then energy just comes down a little bit in many cases. So I think it is kind of a challenge for the buildings industry and energy management, that we have to think about how to be much more flexible and how to only provide the services that are really needed and not have such huge baseloads.
I did a large analysis for a campus of state buildings during COVID, and we found the same thing. The usage had not changed very much, but there's a couple of reasons for that. One is that when COVID hit, we thought this was a few weeks. So we didn't mothball buildings, we didn't turn them off, we didn't turn them down, we didn't change with the way that they were running. And almost all of the buildings that are empty aren't really empty. They're mostly empty, but there's still a few people working there. So they still have to be ventilated and kept at a healthy and safe environment. One trend, though, that we did see, which I guess is not really surprising, because we didn't have the occupants, and this was in the Northwest, we did see some increases in heating usage because people are warm bodies, literally, and they heat the buildings.
That's right.
So we did see some gas usage going up in buildings, even though that they were empty. But I think, COVID is an anomaly. I think if we had had something we thought we were going to mothball buildings for 6 months, it would be very, very different. But we didn't. Yeah. We've never known that. We never know what's next. So it's hard.
Yeah. There was also this countervailing effect, which Paul, I know you're well aware of, but right. Putting buildings in COVID mode, sort of increasing ventilation. So we had efforts that we were doing, to do kind of holiday setbacks with low occupancy, but at the same time, there were moves that were increasing energy consumption. Absolutely. And I think at the end of the day, we went down, we definitely went down, but those are fighting against each other.
Yeah, no, the recommendations from the epidemic task force were not, was to disable a lot of energy efficiency moves like demand controlled ventilation. So yeah, you're absolutely right.
All right, I think given our time, we've got just one last question. And this is one that I'd like each of the panelists to answer, but keep it fairly short if you can. This is going to be a question that's going to kind of be what Carlos would refer to as a war story. What is your most amazing piece of data or data set that you came across in your processes so far? Could be amusing, could be really significant. Just tell us a story. Paul, Reale, do you want to start us out?
I'm fishing for a good one.
Yeah.
Does anybody else ready to get started? Let me think.
I think maybe I have an answer, and I'm going to maybe pick up on the word amazing. I don't know that I think about it about an amazing data point, but I often get a feeling of amazement or really excitement when we're doing work with data analytics. We have a meeting every Thursday, and Raph will bring, we call it show and tell. He shows like something that he's made, and you'll look at it and be like, yes, it's super exciting. It's like you're clapping and barking like a seal. And that is an excitement that comes from the scale and the insight, that we haven't had in old building automation systems. It's really different, in the old world, you're going and you're looking at one air handler and you're seeing those fans turn, and then you're pulling a little trend together. And in this new world, when we've applied all of this metadata and we're looking at it in SkySpark, we build up an application, and it's looking at, in our case, it's looking at 330 air handlers across the entire site. And that's just a level of scale that's exciting, you know, it's amazing, and it makes it fun. And so that's sort of what's most amazing for me. I like this scale that we can achieve now.
You know, one thing that I think is just super cool, and Raf and John showed this real briefly, and I'm not sure everybody got it, and I've heard about it through other projects and other programs. This concept that the lab has built of utilizing information from the IT system to determine the occupancy of the building is just a mind-blowing concept. So they're basically looking at when people have a cell phone or a laptop or something that's connected to the Wi-Fi network, and when it's logged onto the network, they know somebody's in the building. So rather than using security data or schedule data or anything else, they just look at these real-world devices that everybody carries, and they know on average that there's 2.3 devices per person or something, that they have an algorithm figured out. But this concept of actually tracking building occupancy around data that doesn't come from anywhere in the building control system, but comes from the IT system, I think that's a wow thing for me. And I just think that's just super cool. And I'd like to see that done more widely.
Well, I'd like to say two things. First of all, as far as the low fruit are concerned, it seems to me that in the building stock that I've seen, usually the low fruit has to do with scheduling. There's an inordinate amount of systems that are left on. And, you know, I don't wag my finger at these operators. You know, a lot of buildings are understaffed, and they've got 72 air handlers and only 2 people trying to keep an eye on everything. And so it's often the case that these things are left on inadvertently. And there's just tremendous opportunity there. But as far as stories are concerned, you know, I live in a multifamily residential building in New York City, and it was built in 1924, coming up on its 100th anniversary of construction, of having been opened. And, you know, a building like this, you think, boy, it must, you know, act like a piece of Swiss cheese, air flowing through all the time. Being who I am, one day I brought home a CO2 logger, and I set it up in my bedroom. And my wife and I like to close the bedroom door. It's a decent sized bedroom, but what I was finding is that reliably our CO2 concentration was getting up to about 2,200 ppm by the morning. And I thought, wow, that was something I did not anticipate. Is realizing, oh, there are health issues associated with this, and we really want to get, you know, make sure that it's not just a question of reducing outside air, but really making our buildings run efficiently and healthily, and finding those opportunities for where that might be. So that was a real eye opener for me.
You know, just to build on that, Paul, I do have a story that relates to what you were just saying with operator override. I worked on a large hospital project once, and we did a whole series of energy efficiency projects. We cut the energy use by 25% in this urban hospital. It's a big deal. But when the hospital was designed, and it was only 10 or 15 years old, when it was designed, all the units ran all the time except for one unit in the hospital. The only unit that had a schedule on it was the one in the lobby. And of course, it was the schedule had long ago been disabled, and the thing ran all the time. And I pulled the operator aside one day and I said, Matt, why does the lobby unit run all the time? You turn the lights in the lobby off at 9 o'clock at night. I've been in the hospital. I know how this works. He says, yeah. He said, one day, the hospital administrator came up to me at 6 o'clock in the morning, and he says, it's too darn cold in that lobby. I'm going to fire you if I ever come down and then that's a problem again. So he said, I fixed it. So your comment before about reactiveness, he took care of the problem. I mean, the fact that the lobby unit ran 24/7 wasn't a problem, and nobody ever complained again that it was too cold at 6 o'clock in the morning in the lobby. Yeah. So this is what these folks do. They take care of problems. Yeah. Our challenge is to get them to take care of problems and make buildings efficient still.
Yeah, and I just want to put one point on that, which is, you know, and I tell this to my students all the time, we have problems in how building systems are designed, how they are installed, how they are commissioned, and how they are operated. And I don't care whose fault it is. I just want to find the problem and to try to make the best with what they've got. And that I think is important, because, you know, we find those problems run rampant across every one of those phases of a building system. And so it's critical to find those.
Absolutely.
100% agree with that. And I think Paul's point there at the end, that there are times when, especially short-staffed systems, things get overlooked or things get changed intentionally to avoid big issues later. Issues with systems starting up first thing in the morning, always tripping out on low limits in the wintertime. Just leave it running and you avoid that issue, and you don't
Absolutely.
have to spend that time putting out that new fire.
Absolutely.
But we are out of time on this panel. I will invite Paul Reale or everybody do you have any final thoughts you'd like to share?
I will just say it's been great being on this panel with you all. I hope our participants have actually gotten something out of this, and really to focus on that acquiring the data, leveraging the data in clear and simple ways is often the most effective way to go about it. I invite you to go to buildingcoach.org if you have anyone that would like to participate in our pilot program, which is a free in-depth training program. During the pilot, I would be very happy to hear from you.
Fantastic.
I just
Thank you.
wanted to thank the folks from the Best Center and the lab for putting this together and involving us. Appreciate it.
Yeah.
Raphael?
Thank you so much. And I see there's a question from Alice LaPierre. And Alice, I'll send you an email with at least my answer to the question.
Thank you, John, and thank you, Alice. Raphael? All right. Well, thank you, everyone, for your time. Thank you again to our panelists for taking some time to participate with this discussion. Thank you to our audience members for all your great questions. We do greatly appreciate it. And we will see everybody here shortly.
Thanks, Robert.
Thank you, everyone.